Have you ever wondered how your school stores thousands of students' records so perfectly? The answer is database. In this video, we will understand everything about database concepts from scratch. Before we understand what a database is, we first need to understand two basic terms: data and information. What is data? Data is raw facts and figures that have no meaning on their own. For example, a list of employee names, tax codes, or roll numbers. Alone, they tell us nothing. What is information? When this raw data is processed and given meaning, it becomes information. For example, he is going to Delhi is information. It makes sense and is useful. The simple flow is data, processing, information. So remember, data is the input, processing is the work, and information is the output. Now that we understand data and information is a database. A database is an organized collection of related data stored in a systematic, managed, and updated. For example, a school database stores all information about students, teachers, fees, and results, all in one place, well organized and easy to find. Who manages this database? A special software called DBMS, Database Management System, manages the database. It acts as a bridge between the user and the data. Some popular examples of DBMS are MySQL and Oracle. In simple words, a database stores the data and DBMS manages it. Now let's talk about the 4 key properties of a database. These properties are together known as ACID properties. What is ACID? ACID is a set of 4 properties that ensure every database transaction is processed reliably and accurately. These 4 properties are atomicity, consistency, isolation, and durability. Now let's look at each database in detail, one by one. Atomicity ensures that transactions are visible, where transactions either commit or abort. Part fails, the entire transaction fails. Secondly, consistency ensures that changes stay consistent throughout. Third, isolation guarantees that a working transaction will not be affected by any other transaction. Finally, let's look at durability. Once a transaction has been committed, it should remain in the same status even in case of failures. Now we know what a database is and how it works. But why was it created in the first place? Wow! What problems existed before databases? Before DBMS, data was stored using file systems. But file systems had 3 major problems. 1. Data redundancy. Inconsistency. 3. Lack of integration. Now let's look at each problem of file systems, one by one. For example, a student's name and address saved in both the fee file and the result file unnecessarily repeated. When the same data exists in multiple places, updating one file but missing another creates different values for the same data, leading to confusion and errors. 3. Lack of integration. Files were stored separately, with no connection between them. It was very difficult to combine or relate data from different files. What are the characteristics? The main characteristics are as follows. 1. Real-world entity. 2. Relation-based tables. 3. Isolation of data. 4. Less redundancy. Now, let's look at each characteristic of DBMS in detail, one by one. 1. Real-world entity. In a school database, student is an entity and age is its attribute. Let's move on to the second point, relation-based tables. DBS organizes entities' relationships into tables, so a user can understand the database structure just by reading the table names. Let's discuss isolation of data and application. A DBS and its data are 2 separate things. The data itself is passive, it simply exists until the system works on it. Now for our final point, less redundancy. A DBS normalization to reduce data repetition. This ensures the same data is not stored in multiple places unnecessarily. Let's define the different types of users of DBS. First is the DBA, or Database Administrator. This role manages everything. Application programmers write programs for the database. End users use applications without knowing the backend. And system analysts design the structure. Let's discuss the advantages and limitations. Advantages include less redundancy and better sharing. However, expect high hardware and maintenance costs. What is the relational model? It represents how data is stored in relational databases. A relational database stores data in tables. Let's look at terms in the relational model. A tuple is a row and an attribute is a column. Also remember that a relation is simply a table. Degree is the number of columns and is the number of rows. Now let's understand one of the most important concepts in a relational database, keys. Look at this student table. How do we uniquely identify each student? The answer is using a key. What is a key? A key is an attribute or a set of attributes that uniquely identifies a row, tuple, in a table. Key is like a student's identity. In this table, ADAMNO can uniquely identify every student. No two students have the same ADAMNO, so it is unique and always different. A candidate key is an attribute of attributes. They can uniquely identify a tuple. Admission number and roll no are candidate keys. Let's consider a student table. Here, the admission number is the primary key. A primary key uniquely identifies a record, and it cannot be null. A foreign key links two tables together. Here, the admission number column creates a relationship between the student table and student detail. Welcome back. Today, we will explore SQL commands. DDL defines the database structure. Commands like create, let's study each command one by one. The create command makes a new table. Here's how to create a student table. Admission number is the primary key. Now we will learn about the drop command. It is used to drop an existing table. Next, the truncate command. It removes all records from a table. Now we learn about the rename command. It is used to rename a column in a table. Next, the alter command. We use it to add a new column to a table. Now we transition to DML. It includes select and insert. It allows you to manipulate data. Finally, we have update and delete. Now we move to DML commands. First, we use select to retrieve data. Next, the insert command. It is used to add data to a table. Now we come to the update command. It is used to modify existing data. Notice the where clause is very important here. Finally, the delete command. It removes records based on a condition. If you enjoyed this video, please like, comment, share, and subscribe Tech AI for more videos like this.